Hi, this notes video will go along with finding how to multiply polynomials for Algebra 1. This should go along with your notes page. You can pick up from your teacher. So there's a little warm-up problem, just something to think about. I'll talk through here. And you learned how to do area a long time ago when you were just a kid, but area is length times width, right? So we all know 3 times 5, 15. When you have this shape, though, it's not 3 times 5. And then you can kind of continue on the same type of thinking with variables as the sides. We don't even know what the dimensions are. So if you break something down into smaller rectangles, you may be able to figure that out. And then we'll go through that in a second. So pause it and work them out, see if you can figure out the answer. So we're going to apply basic properties of exponents and multiply polynomials. So we talked about this, right? The area already, 3 times 5 is 15. That's 15 square units. For this one, maybe you figured it out, but you can take 3 times 5, which is 15, and then this one is 4 times 3, which is 12. 15 plus 12 is 27. The other way you could do that would be, you know that 5 plus 4 is 9. 3 times 9 is 27, and that also works. So we're doing variables here. So if just like with numbers, you'd multiply. We multiply the coefficient. 3 times 2 is 6. We multiply the variable. They have the same base. This is a power of 2. That's a power of 1. 2 plus 1 is 3. 5 times 3 is 15. 15x squared. Now these are not like terms. So that would just be our answer. It would be an expression that looks like that. Same kind of thing here. We have 4 rectangles. 3x times x is 3x squared. 3x times 3 is 9x. 4 times x, and 4 times 3. Now, the thing you might notice here, though, we do have some like terms where we can add. So we'd have 3x squared plus 13x plus 12. Okay, and so that is the area of that shape, if we knew more about that. Well, the other way we could find the area of that shape is if we knew what x plus 3 was, and we multiplied it by 3x plus 4. So essentially, we have come up with a way to multiply these two together to get that. I don't know how these got on here. Okay, so when you are multiplying two monomials like 3x and 5x squared, you multiply the coefficients, so that would be 15, and you add the exponents. So x to the first plus x squared, x to the third. So when we multiply those two things together, we get 15x to the third. You always got to put your 1 there so you don't forget about it. There's another example. We're going to skip over that. There's a couple examples you can see. Okay, so let's get into the heart of doing these problems here. So basically what we are doing with multiplication is just doing the distributive property. So I can distribute this 6r. So that would be 36r squared minus 12r. I'm just distributing a monomial here. So that would be 15v to the third. Remember, I have a 2 and a 1 minus 12v squared. There's no v here, but the number still comes along. Okay, so the other way this can happen is you could do the box method, and we still get our same numbers, right? So we can set this up. If I have one term and two terms, I have a 1 by 2 box. So either one of those methods works and we get the same thing. When there's only a monomial, my suggestion is just distribute. So if you're making a box, you want to think about that concept. Boom, boom, boom. it's the same thing as if you distribute. So the n to the third and the m squared got combined. 6 times 7 is 42. 6 times 4 is 24. You'll see later when this box method why it might work. So I'm going to do this. 5 times 4 is 20. A squared, a to the fourth. 5 times 7 is 35. A squared times a is a to the third. B just along for the ride. 5 times 3, or negative 3 is negative 15. A squared, b squared. So you notice they didn't have anything combined. They're just, again, along for the ride. Okay. So when we get to one like this, now we have two things we're distributing. So 6v times 6v is 36v squared. 6v times negative 8 is negative 48v. Then I got to distribute the negative 4. So negative 4 times 6v is negative 24v. Negative 4 times 8 is 32. So I do have some like terms right here. That I need to combine. Okay, so that is one way to multiply these out. The other way would be to make a box. And so if you notice, I just want to show you how this is here. There's the 6v minus 8. Here's the 6v minus 4. And then we just multiply like we did on the warm-up problem. The thing is, when you make this box, the like terms line up on the diagonal. So you're always going to need to check the combined like terms. Okay, so go ahead and multiply number 6 any way you want to. You can either do the distributive property twice, or you can set up the box. 8x plus 1, 4x plus 4. Notice the signs. 8 times 4 is 32, x squared. 4 times 1 is 4x. 32x plus 4. 32 plus 4 is 36. So again, either method works. It's just got to be able to multiply. Again, set it up yourself. See if you know what you're doing. Pause it, see if you can multiply. It's the same problem, different letters. There's the second one. The first one I'm going to set up and do this. So 9x squared minus 6xy, 24xy, negative 16y squared. Again, look at my diagonal. Those are like terms. So we have 9x squared. 24 minus 6 is 18xy minus 16y squared. You do this one either doing the distributive methods or make a box and get your answer to match up with that answer. You have to show your work to your teacher. Okay, same thing. Double distribute if you want. Make a box if you want. Make this box here. Again, if there's 2 terms here and 2 terms here, it's a 2 by 2 box. I'm just distributing all these. And then I'm looking at my diagonal. And those combine to give me nothing. 24 minus 24. So my final answer is 64k squared minus 9. And notice up here it said what happens. What happened here is that these went away. And the same thing happens over here after you do this problem. Well, what you might notice is that 2n and 2n, and then we have a plus 1 and a minus 1. You look at this pattern, 8k and 8k plus 3 minus 3. That is a pattern that will come up later when we unmultiply, or what's called factor. Okay, here's the last kind of problem we want to make sure that you know how to do is if it says this is squared, that means to the second power. Notice over here in bright yellow it says rewrite. Make sure you write this out, and then you can multiply it however you want. I'll do this one with distributive property. M squared plus 5m plus 5m plus 25. So again, the like terms are there just like they would be in the box. If you do this one, rewrite it like that. And so we have the same kind of thing is going to happen. If you notice, you might even be able to come up with your own little shortcut. You notice here negative 28 and negative 28 is negative 56. Okay, so we make sure you rewrite it. If you don't rewrite it, you often forget this middle term. Okay, now the big ones. This is one where I definitely recommend that you make the box if you want to keep things nice and lined up. It just helps. So I'm just going to go right to making that m minus 7, and then I'm going to put 6m squared minus 8m minus 5. I always write the numbers and then I make the box to fit. So now I'm going to do my multiplication. So this is 6m to the third minus 8m squared minus 5m. Notice the powers are all getting one smaller. Now I'm going to multiply the bottom. Negative 42m squared plus 56m plus 35. And so if you'll notice on these, we have the diagonals are the same. There's more than one there. So negative 42 plus 8, negative 50. 56 minus 5 is 51. So the powers go from highest to lowest, and if you have something jumps away from that, you probably should check it. So go ahead and pause and try to do number 14. There's your answer. If you were multiplying using the box, which I recommend, especially for this one, it looked like that. Again, these diagonals were going to be the same. I will do one of these using the distributive property for those of you that are doing distributive property. You multiply it, 3b to the third plus 15b squared plus 3b, and then you got to multiply this one, and you just line up the terms. So that way you're combining your like terms along this diagonal. Okay, so again, pause and do this one. Divide it up. 8n to the third, 20n squared, 32n, 2n squared, 5n, 8. There's your like terms. 8n to the third plus 22n squared plus 37n plus 8. So back to our original problem, they may ask you for the area, and you just would multiply those together, even though we don't know the numbers. Okay? That's all we have for this video. It's kind of a long one. Ask your teacher if you need help or if you need to decide between the box method or just straight distributing.